Hello my dear students, welcome to one more amazing session from Sri Chaitanya Academy Infinity Line NEET YouTube channel. So आज हम चर्चा करने वाला है aromatic hydrocarbons का. So how are you all my dear students? Very a few days, just 2 weeks to go for your NEET examination. So you tell your confidence level and how you are doing. So at the last moment of your NEET examination, I just want to give you a and ever touch any topic that is new to you. So believe one thing, no student is going to complete the 100% of the syllabus, and you may be doing 95 or 96, 99, 99.9 maybe, but it cannot be 100%, let it be. So I wanted to say, be confident whatever you studied so far. Never learn anything new at this moment, and revise what are the things you just did so far and do as many as your mock test. Yes, so all the best my dear students. So let us start hydrocarbons in the organic chemistry and meta-analysis. I have Palak, how are you? Palak, how are you? So in the organic aromatic hydrocarbons, you will be having only one thing, benzene, golden reactions of benzene. So let's see, it is undergoing, benzene undergoes electrophilic aromatic substitution reactions. 5 golden reactions of benzene. They are halogenation, nitration, sulfonation, Friedel-Crafts alkylation, Friedel-Crafts acylation. So in detail we will see about these reactions and short recapture of these golden reactions of benzene. When you see, it is an electrophilic aromatic substitution reaction, bachcho. Benzene just like like alkene, but it is not participating in addition reaction. Because of the delocalization of the pi electron system above the ring and below the ring, it is going to participate in a substitution reaction by the electrophile, so it is called as the electrophilic aromatic substitution reaction. So the electrophile is going to attack by the pi bond to make a sigma bond which is resonance stabilized, so it is called as a sigma complex. And this sigma complex is going to be deprotonated to give rise, one hydrogen of the benzene is replaced by an electrophile, so this is an electrophilic aromatic substitution reaction. बच्चों समझ में आ रही क्या? Now moving ahead here, so in the halogenation, benzene react with chlorine to give us chlorobenzene, and in that scenario chlorinium ion, you see here the mechanism, you see the chlorine lone pair of electron present on this chlorine is going to taken by this AlCl3, which is acting as a Lewis acid. So what is the use of AlCl3? It is a Lewis acid and it is a electrophile generator and it is going to be a catalyst. You are going to get an electrophile, Cl plus is going to be the electrophile, otherwise you can say that. And that electrophile is going to attack on this benzene, the pi bond. You are going to see the formation of the sigma bond with sigma complex, which is a resonance stabilized, and it is deprotonated to give rise chlorobenzene and AlCl3. The catalyst is going to be regenerated, bachcho. So this is how it is happened, the chlorination of benzene. So the question comes like, it is Palak, which of the following is an electrophile, which of the following is the intermediate, sigma complex is an intermediate, like this nitration of benzene. So benzene react with nitration mixture and HNO3, H2SO4, and you are going to get a nitrobenzene. And this is a generic mechanism. Let us see here the mechanism. When you see the mechanism here, HNO3 is a Lewis base. This is a very important, and this is going to be a proton donor, so it is an acid. It is an acid base reaction to gives rise nitronium ion, which act as an electrophile. This nitronium ion is going to attack on the benzene to gives rise a sigma complex. This sigma complex is resonance stabilized. Okay, Palak, hope you understand. Shahil is there in the class today. Bacho? Right. Now, let's see. This is deprotonated to gives rise its corresponding nitrobenzene. You know, this is the chief ingredient in the perfumes and deodorants. So, this is nitrobenzene. Now, let us talk about sulfonation. Quick recapture. You want to study this, it takes hours time, and within a short period of time I am going to recapture. Just examinations are just above you, and we'll do it best. So this is a benzene sulfonic acid. How this is generated? You are going to use mixture of sulfur trioxide and concentrated sulfuric acid, and this is called as fuming sulfuric acid. In this fuming sulfuric acid, the pi bond of this lone pair of electron on the sulfur trioxide is going to abstract the proton to give rise an electrophile. So which of the following is an electrophile in this reaction is going to be a very good question. Okay, and this is seen here, and this electrophile is going to attack by the pi bond of the benzene to give its corresponding sigma complex resonating structures. Bacho, in this corresponding resonating structures, and these resonating structures deprotonation होने के बाद आपका क्या होगा? Benzene sulfonic acid will be generated. You know, this benzene sulfonic acid, this process is going to be reversible process. So let's see here, very important thing, among all the reactions, all are irreversible reactions, and this is going to be the reversible reaction. So अगर आप आगे हाइड्रोलाइज करेंगे तो फिर बेंजीन ही मिलेगा. So I mean to say here, if this is treated with Hu plus and H2O, you are going to get a benzene. That's a very important noteworthy point in catching the pointers in the NEET examination. Bacho, halogenation, the electrophile is going to be Cl plus, nitration NO2 plus, and it is going to be SO3H plus. Okay, here R plus, and you are going to get RC double bond O plus. So like that, various things are there which I already discussed in the previous classes as well. अगर कुछ doubt है ना तो जल्दी बताओ, so that we can start the classes. बच्चों, we can start the questions now. We can start the questions after reading this. After reading this, I just want to say, इलेक्ट्रोफिलिक एरोमेटिक सब्स्टिट्यूशन होने के बाद आपको डायरेक्ट इन्फ्लुएंस के बारे में बात करना बेटा. That's very important. So those students who are online, come on. So electrophilic aromatic substitution reaction, these are all done. Chlorination, nitration, sulfonation, and you say Friedel-Crafts alkylation, and this is going to be Friedel-Crafts acylation. Now I want to say this is an awesome concept in a NEET examination, directing effects in electrophilic aromatic substitution reaction. In this electrophilic aromatic substitution reaction, so I want to say here it is an example, anisole. इसका नाम क्या बेटा? Anisole. Methoxybenzene. So this is your methoxybenzene, lone pair of electron present on this. Lone pair of electron present on this oxygen is going to donate the electron. So that what will happen, ring is getting activated, so that you are going to get ortho, and the para is going to be the major product. Whenever electron releasing effect is there, it could be usually positive resonance effect or positive mesomeric effect. You are going to get ortho and para directors, and these are due to reactivity is more ring activated and ortho and para director. Okay, and that's why you can see when this ring is given electron by means of positive mesomeric effect, you are going to get a major contributing structures, and the resonating structure, the negative charge is accumulated at ortho and para positions. Whenever electrophile wanted to attack here, the electrophile can attack here, can attack here, can attack here. That's the reason why you are going to get ortho and para position. If you see this methoxybenzene, the other side of the coin, right? So students, you have any doubts, you can ask us. Now let's see here the activation energy for this meta product, activation energy for the ortho product, activation energy for the para product. So lesser the activation energy, more is the formation, and major is the reacting. So this kind of graphs which is connected in terms of organic chemistry to physical chemistry, and assertion reasoning based questions also will be asked, more application oriented things here. So this is a very important. So अगर कुछ डाउट है ना तो जल्दी पूछना. And similarly और एक चीज़ है, that's the reason why anisole is treated with chlorination. You are going to get orthochloro and parachloro. Among para is the major product. Fine. So my goal at stats, meta analysis, and Palak, come on. So at the last days of this NEET examination preparation, these logical questions are important. और एक चीज़ आपको बताना चाहता हूँ. So you have strongly activating groups है, वो H, वो और NH3 and NR3 and NH2. And those having a positive mesomeric effect because they have the lone pair of electrons on it, isn't it? Like this. And also you see moderately activating whenever it has मान के चलो ये group a benzene है, okay, if it has a positive mesomeric effect, it has a cross conjugation. It has a cross conjugation. That's the reason why it is a moderately activated, right? Moderately activated. And weakly activating groups like a positive inductive effect or kind of things, chameleon groups are also there, can have the weakly activating groups. Bacho. Fine beta. And you see, अगर electron withdrawing group आना है तो क्या करूँ? Whenever positive mesomeric effect is there on the benzene, ring is getting activated, the product is going to be ortho and para. And such groups containing ring is more reactive as compared to the ring. While it can see if any group is having negative, so you are going to have the various groups and sigma complex positive charge is accumulated at ortho and para positions, so that electrophile can never come and attack at ortho and para positions. So positive cannot crack at positive, so rather it is going to attack at meta position, less likely. If you see this activation energy diagram, you are going to get traces of ortho and para, and you are going to have the relatively major at the meta position. Moving ahead, you can see the activation energies for this. So the resonating structures, the electrophile attack at the ortho will have unstable one, electrophile attack at the para will have the unstable one, but electrophile attack at the meta position is a relatively stable one. So that's the reason why in this case the activation energy for the meta sigma complex is going to be very less as compared to ortho and para. As a result of this, the product you are going to get in this reaction is going to be a meta directing product. So that's the reason why strongly deactivating group CF3, NO2, NH3 plus, and moderately deactivating groups. So any carbonyl groups or carboxylic groups and their derivatives are going to be moderately deactivating groups. But halogens comes now, they are going to weakly deactivating, but exceptionally they are ortho and para adduction. So in the entire scenario of the bandwidth, you will be seeing total I wanted to show you, and it is going to be strong activating, moderately activating, weak deactivating, moderately deactivating, and strongly deactivating. Wherever activation is there, ortho and para directors, and wherever deactivation is there, meta directors. But formation of benzene from acetylene is, how do you form benzene from the acetylene? You can see, you are going to see CH triple bond CH and CH triple bond CH and CH triple bond CH. This is passed through copper tube, red hot copper tube. So you are going to see the formation of this benzene like this. So it is trimerization, cyclic trimerization. Fine. The answer for this question is going to be 1. Simple one. Hope you understand, bacho. Come on. Moving ahead, और एक क्वेश्चन है बेटा. This is one carbon hydrogen bonds in the benzene are. In the benzene you see the carbon to hydrogen bond. This is going to be sp2 carbon, sigma bond, pi bond, sigma bond. So sp2, this is s orbital, sp2 to s sigma bond is going to be formed. So the answer is going to be 1. Moving ahead, one more question, my dear students. Maximum number of atoms present in a plane of benzene. So in the plane of benzene, I already shown there are 6 carbons and there are 6 hydrogens. So carbons are 6, hydrogens are 6. I would say my answer is going to be 3. 12 atoms are there in the same plane. That's an outstanding answer for this question. Bacho, come on. And you can say, why does 1,3-cyclohexide ion undergo dehydrogenation readily? So 1,3-cyclohexa, 1, 3. So 1, 2, 3. So it undergo dehydrogenation. When it undergo dehydrogenation, it is going to have aromaticity. 2 hydrogens are removed ताकि इसका बेंजीन बनेगा. So that resonance के हिसाब से it gains a considerable stability becoming benzene by aromaticity. By aromaticity. See why reasoning type questions. Whenever it is said why, it is a reasoning type question. समझ में आ रही है क्या बेटा? Right. And halogenation of aromatic compounds, the catalyst is, you can use this benzene, halogenation, chlorination, you can use any Lewis acid, you can also use AlCl3, you are going to get a benzene, right? So this is either FeCl3, either BCl3, BF3, AlCl3 or any halogen carrier can be used. The answer for this question is going to be 4. So बच्चों, hope you are understanding. अगर कुछ doubt है ना तो जल्दी 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 बताना पड़ेगा. Okay, now let us talk about nitration. So concentrated HNO3 and concentrated H2SO4 equimolar mixture is called as a nitration mixture. So my answer for this question is 1:1 of these. Got it clear? Now benzene reacts with dash to yield acetophenone. Now what is acetophenone? Benzene, if it is reacted with, you are going to get, this is what is called acetophenone, CH3. So CH3 COCl in the presence of AlCl3. This is what is called as the Friedel-Crafts acylation. The answer for this question, it is given as CH3COCl and AlCl3. Fine. Palak, hi. Shalu Kumari, how are you, Palak? Now one more question, bacho, one more question. Palak, next question. Either you give the answer or you want me to give the answer. Come on, let's say here it is given phenol zinc dust. It is going to react with that here to give B. What is the answer for this question? Bacho, jaldi. Jaldi. Benzene react with zinc dust. You are going to give you benzene reduction. Now the benzene is going to react with C6H5COCl. So that is going to give you C6H5. So I mean to say this is what is called as a benzophenone. So the answer for this question is going to be benzophenone. Clear? Thank you very much, Palak. Thank you for your compliments. One more question, ready to give the answer. Come on. So C2H2 Huckel metal tube. Cyclic trimerization takes place. A is going to be C6H6 and A is treated with the fuming H2SO4, gives rise fuming H2SO4. So you will be having SO3H, sulfonation of benzene. B is going to give SO3H. So it will be benzene sulfonic acid. So benzene sulfonic acid. CC, crystal clear. Am I right? Crystal clear. Now one more. The answer is 3 here. Whatever you have given, correct answer. Now moving, number of double bonds in the gammaxine, BHC. It is going to be 0. What is gammaxine? This is a C6H6. When it is treated with the Cl2 in the presence of heat and light, you are going to get Cl, 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 Cl. Okay, उसमें कुछ हाइड्रो डबल बॉन्ड्स नहीं है. That is C6H6Cl6 666 compound. This is what is called as 666 compound, gammaxine. Fine, that's good. Now the answer is going to be which of the following represented incorrectly? Correct, correct is an example of Friedel-Crafts reaction. Correct. Distillation of phenol with zinc gives rise to benzene. Correct. Benzene react with acetyl chloride in the presence of AlCl3 gives rise C6H5COCl. This is not correct. Why? Because benzene react with CH3 COCl in the presence of AlCl3 gives, you will be having C double bond OCl, acetophenone will be formed. Acetophenone will be formed. So this is the incorrect answer is going to be 4. Hope you understand बच्चों. अगर कुछ डाउट है ना तो जल्दी बताना. So बच्चों और एक क्वेश्चन है आपके साथ. So wrong statements in the following is. So sulfonation of a benzene takes place only with hot concentrated sulfuric acid. So you have to find out wrong. In the nitration mixture, concentrated sulfuric acid is used for the formation of nitronium ion. Correct. Because of unsaturation, the benzene easily undergoes addition reaction. False. Due to delocalization of pi electron system above and below the ring, and it is said that benzene never prefers to participate in addition reactions, so rather it is going to participate in substitution by electrophile. So benzene prefers to participate in electrophilic substitution reaction. So benzene bonds with the Suti flame as it is an aromatic compound, it is true. So my question, A question का हमारा आंसर ऑप्शन 3 होगा. फाइन. Any doubt बच्चों जल्दी बताना. Now one more. Which of the following is again a wrong statement? See, NEET examination is now testing you the understanding abilities. You have to check whether it is wrong, right, correct, incorrect, various statements you need to. So the electrophile in sulfonation is H2SO4. In Friedel-Crafts reaction, the benzene with an acid chloride and electrophile is RCO plus, correct. In the nitration of toluene by electrophilic substitution reaction, electrophile is nitronium ion, correct. This is correct, this is correct. And the reaction of benzene with chlorine in sunlight is an addition reaction. Gammaxane C6H6Cl6 is going to be formed. And in this electrophile in sulfonation is going to be SO3 hoga, H2SO4 nahi hoga. Option 1 is the correct answer for this question. Fine. Now one more. The question is coming like this. Which of the following is not correct? Again, which of the following is not correct? So benzene can be obtained by the cyclization of ethene, wrong. Ethyne hoga, right? And benzene react with H2 in the presence of nickel at 200 degrees centigrade high pressure to give cyclohexane, correct. C6H6Cl6 can be obtained from, yes, benzene with chlorine in the presence of light, correct. Benzene react with ozone to form benzene triozonide. It is also correct. So ozonolysis में 3 moles of glyoxal भी निकाल सकते हैं. Answer for this question is 1. Any doubt? अगर कुछ doubt है ना तो जल्दी बताओ. One more question. Benzene does not undergo addition reaction easily because due to complete delocalization of the pi electron system. So it's 6 hydrogen cyclic system, double bonds present in the benzene is strong, resonance is stabilized by the system is preserved. That is supposed to be the correct answer, bachon. So the answer for this question is going to be 4. Very elementary level question, but looks complicated when they form a proper statement like this. Okay, dear children, one more question I just want to give you. Under pressure with hydrogen in the presence of nickel catalyst, benzene forms. What could be the answer? It is going to be under pressure, it is going to form cyclohexane. If you don't use high temperature pressure, it cannot be, right? One more. So carcinogen pollutants are formed in incomplete combustion of coal, petroleum, tobacco, all the above. Carcinogenicity is there in the grade 11 NCERT last part of the textbook. In the organic chemistry, hydrocarbons. So answer is going to be 4. Fine, beta? Clear? Now, so benzene and polynuclear hydrocarbons containing more than 2 benzene rings is used together, or they have the carcinogenic properties. All the above, they are toxic, causes cancer, possess carcinogenic properties. Fundamental questions only. So these are simple questions, simple corners of the carcinogenicity kind of things students usually miss in their regular level of preparation. So I strongly believe that do this and you can do the best in the examination. Or a question, among the following, which is carcinogenic pollutant? 1,2-benzopyrene, okay, 2,1,2,5,6 dibenzanthracene and 3-methyl colanthracene. And I strongly feel it is all the above. Kabhi ye sunai nahi kya? And these are there in the NCERT textbook. NCERT textbook mein machotism. Okay, fine. It is there in the NCERT, bacho. And one more important thing, how many of the following groups are activating towards the electrophilic aromatic? Whenever, yes, whenever a group is there and that group, let us say a group has a lone pair of electron, it can show positive mesomeric effect. Whenever it show positive mesomeric effect, ring is going to be activated. Ring is going to be activated. Fine. So I could say this ring activated, this ring activated, and this is deactivated, this is activated, this is activated, this is activated, this is activated. I want to say 1, 2, 3, 4, 5, 6. Answer is going to be 6. Fine. So like that you will be having so many questions, the same meta directing. So this is ortho and a para directing, and this is a meta directing, this is ortho and a para directing, this is ortho and a para directing. I could find only one is there as a meta directing group. Yes. Hope you understand. Like that so many questions are there, like that you can do. As the time is exhausted and I am done for today's class. Tomorrow we will meet with halogen compounds, haloalkanes and haloarenes. Ready for that? And all the best. Write your mock test at the end of these days and you do the best. Okay. So signing off from YouTube channel, Sri Chaitanya Academy Infinity Line YouTube channel. So we'll meet again tomorrow. Thank you very much. Thank you.